Your Next.js app is crashing your PostgreSQL database. It handles requests fine, until too many connections keep coming. Pool exhausted. Here is how to fix it step by step. Problem 1. Serverless connection inflation. How isolated lambdas exhaust database connection limits. Every serverless function opens its own database connection. 20 lambdas equal 20 direct connections. The pool fills up fast, 50 out of 100. 100 out of 100 critical. Connection limit reached. The solution. A transaction pooler like pgBouncer or Supabase pooler. It sits in between and multiplexes your connections into just a few stable pipes. But most people write code like this. A new PrismaClient on every request. 100 requests equal 100 connection pools. This is the problem. It explodes your database. The fix is simple. Use a global singleton, cache your connection, and add a pooler URL with pgBouncer equals true and a connection limit of 1. Your database stays healthy, even under load. Problem 2. Development HMR connection leaks. How Next.js fast refresh spawns orphan ORM instances in local development. Every file save triggers a hot reload. The module reevaluates, creating a new PrismaClient. Save 1, 10 connections. Save 2, 20 connections. Save 3, 30 total. The pool exhausts fast, 100 out of 100 exhausted, unable to open connection. The solution, bind to global this. It persists across reloads. Save 1, create and cache. Save 2, reuse existing. Save 3, reuse again. 0 new connections. Connections stay at 10. But most people export a new PrismaClient. It re-executes on every file saved during npm run dev. This leaks connections in local development, and your database fills up fast. The fix is simple. Use global this as a persistent cache. Create once, reuse every time. Save to the global scope only in development for an HMR-safe singleton. Problem 3. Session versus transaction mode misconfiguration. Using session pooling defeats the purpose of serverless poolers. Session mode pooling, 10 lambdas send queries. Each bonds to a pooled connection for its entire lifecycle, even while idling. 10 out of 10 connections locked. Lambda 11 arrives, no free slots. Connection pool timed out, all bottlenecks at the pooler. Transaction mode pooling on port 6543. Connections are released instantly after each SQL transaction and handed to the next lambda in a round-robin stream. 2 out of 10 connections active. High-throughput multiplexing. But most people use port 5432, the session mode direct port. It locks the connection during container idle time, making it completely useless for serverless. Works in production. Maybe, but it's wrong. The fix. Use port 6543 for the transaction mode pooler and add pgBouncer equals true. Connections free instantly after every query. Reserve port 5432 for direct URL migrations. Problem 4. Unbounded client pool size in serverless ORMs. Default ORM pool settings multiply connections exponentially. Default ORM behavior, 10 connections per client. 15 serverless lambdas times 10 equals 150 connections. If the pooler is capped at 50, 150 incoming requests try to fit into 50 max slots, causing pool size to be exceeded. The fix is simple. One HTTP request needs only one connection. 15 lambdas times 1 equals 15 connections. 15 out of 50 connections, perfectly stable. Set the connection limit to 1 on serverless client strings. But most people use default pool settings with no connection limit. Prisma defaults to 10 per client instance, which multiplies across lambdas and exhausts the pool fast. The production fix. Set a connection limit of 1 and a pool timeout of 10. Enforce strict serverless limits, 1 slot per lambda. It never exceeds the pool cap and stays safe at scale. Problem 5. Runtime database migrations in serverless. DDL schema migrations inside API routes cause table deadlocks. Next.js deploys a new build, and 10 lambdas boot simultaneously. Each runs Prisma migrate deploy. Lambda 1 grabs an access-exclusive DDL lock. Lambdas 2 through 10 hit a concurrent DDL lock timeout, resulting in a P3009 migration failure and crashing the deployment. The solution. Decouple migrations from runtime serverless. Your CI/CD pipeline executes migrate deploy once using a direct URL, then lambdas deploy without running migration code for a safe, ordered deployment. But some people execute migrations inside API routes using exec-sync. Concurrent lambdas lock the database table and crash production on every deployment. The fix: move migrations to a build time CI/CD pipeline. Use DirectURL for Prisma Migrate Deploy, executed once before serverless deployment for a safe, ordered pipeline. So to quickly recap, if your Next.js app is overwhelming your Postgres database, these are the 5 fixes that matter the most. Use a transaction pooler like pgBouncer or the Supabase transaction pooler. Create a global Prisma singleton to avoid connection leaks during development. Use transaction mode on port 6543 instead of session mode. Limit your serverless connection pool to just 1 connection per Lambda, and never run database migrations inside your serverless functions. These 5 changes alone can prevent connection exhaustion, pool timeouts, HMR leaks, migration deadlocks, and a lot of production headaches. Thanks for watching. I hope this video helped you understand why Postgres connection issues happen in Next.js and how to fix them properly. If you found this useful, please subscribe to the channel, give this video a like, and check out my other videos on Next. I'll see you in the next one.